Well, hello, my algebros. Let's go through the study guide for your test, which is tomorrow. The first question is to plot and label, right? So we just want to know if you know this is the x value and this is the y. We obviously start at the point of origin and then I go over on the x-axis, -2, and I go up a +4, and then I would put a point there and I would label it A. For this point over here, it is 3, 5. On number 2, it asks for the domain and the range of the following relation. Remember, a relation is just a series of points. Could be a function, could not be a function. That just depends on what's going on there. So our domain are all of the x values. So we have 1 and 2 and 3 and 3 and 6. And how we write these is in number order, but we do not need to repeat the 3, right? For the range, we do the y values, which are 2 and 1 and 1 and 2 and 6. But these we need to reorder so that it's the smallest to the largest, and again, not repeating any of the values. The next question is this a function? And no, it's not a function because the x values are repeating. The x value 3 is repeating. So x values can never repeat or they cheat and it's not a function. Y values absolutely can, but not the x values. All right, on number 3, we're trying to figure out which of these multiple choice answers fits this representation. We have time on the x-axis and temperature on the y-axis. We can see that the temperature rises over time, so we're looking for something that's increasing. This is an increase. This says stay constant, decrease, and increase. So immediately we know B and C are out because they do not say increase. After that, it goes to staying the same temperature, and this stays constant, and this says decrease. So right now we're thinking this one's out as well. Then it rapidly increases, which could be either with these, but it doesn't matter because this one doesn't decrease. So we know that D is the correct answer. On number 4, it asks for the domain, but this time we're given a graph. So these points have been graphed. It turns out it's a linear representation. So all the points on this line are solutions. So we're looking at just the x-axis, the x values. So the x values are over here, and we're figuring out that it looks like 2 is the largest it can go. It doesn't go beyond 2. And -4 is the smallest it can go. So we can write this as an inequality. If we think of our number line here, where we have 2 and -4, we know that we can write this as an inequality representing these values in between, right? Because it can be 2 or less than 2, all the values over here, and it can be -4 or greater than -4, and nothing else. On number 5, it asks for the range, and we know that's the y values, which is why B is correct. Oh, by the way, this one was also a multiple choice question. On number 6, it asks us to find the function rule, right? Well, we could do process of elimination, or we could just solve it. We check to see what it's going up by, and we can see that it's going up by 4 every single step. So we know that means that it has to be 4 times this, because whatever this value is, it's going to go in front of the function x. So then when we put 4 here, we multiply 4 times 1, and what do we have to add to get to 8? Well, we have to add 4, and we can check it like on 4. 4 times 4 is 16, plus 4 is 20. So we know this is the correct function, which we find right here is B. On number 7, we've represented this with the Play-Doh machine today, just talking about functions, and a function is like a machine. This is our machine here. We're finding out that y is always dependent on what the x value putting it into the function is. So f of x is the same thing as y, and we're seeing that it's 6x minus 1. If x is 4, then we would substitute that in and we get 24 minus 1, which is 23. And of course, we want to write our answer in the form of a point, right? Our x and our y values. Because when x is 4, y is 23. On the next part, when x is negative 5 and we substitute that in, we see that when x is negative 5, y is negative 31. Right? Don't forget that when you're doing this, you would add a negative, which is why it's negative 31. All right, on number 8, it's saying what is the dependent variable? Well, we know that y is always dependent on x. So we're looking for what's the y value here if this was to be in a graph. And it says that soda sells for $1.50 per bottle. So we know that on the x-axis would be how many bottles, 1 or 2 or 3 or 4, so forth. And then the cost of those would be $1.53 and then $4.50, which is telling us that the cost of the soda is the dependent variable because it depends on how many you buy, which is the independent variable. On number 9, we're writing a function for Joey in his savings account that he has $200 and he's saving $75 per week. Now we've been doing a lot of these functions since school started, actually. Back when Tia and she was comparing Truthful Tom with Fair Fred and all those other functions. But now we're just really calling them functions. So f of x is to give you a y. Y is always the money, right? And how much money does he have? He has $200 already and he's saving $75 a week, or 75x, right? This is how we can write it either way. These are fine. And then it says how much will he have after 8 weeks. So if it was f of 8, or when the weeks equal 8 weeks, how much money does he have? Well, we have 75 times 8 plus 200. And 75 times 8 is 600 plus the 200. So we know in 8 weeks he would have $800, right? All right, number 10, all 10, 11, and 12, all are represented in this question here and in this visual representation there. Now, the graph tells us that this is 14 and 26, but you could go ahead and count this out and find that for one table, you have 14 seats, and for 2 tables pushed together, you have 26 seats, and for 3 tables pushed together, you have 38. After that, you know that it's going up by 12 every time, so you can finish the table. 38 and 12 is 50. 50 and 12 is 62. On 11, we write the function rule, and we know it's added by 12 every time. So we know we're going to be multiplying the x value by 12, or getting 12x. And then we need to see, how do we get to 14? Well, 12 plus 2 equals 14, so that's why we're adding 2 here. Either way you write it, it's fine. And then you can use this function rule to solve number 12, which is if they put 11 of these big tables together, will there be enough for 133 people? When there's 11 as the x value or the table value, will you have enough? So we substitute it in, we get 132 plus 2, which is 134, and that would be, yes, that's totally enough with a 1 left over, right? All right, the rest of these this is how large the actual mini test is. The rest of the study guide is just extra practice for you to get really comfortable writing functions. So on the toothpick one, When we count the toothpicks, we see that 6 toothpicks are used. On the second one, 9 toothpicks are used. The third one, 12 toothpicks are used. And so that means that it is going up by 3 toothpicks each step, right? And of course you can draw the next set in there, and I believe they ask you to do that. So I'll just switch colors really quickly. We always have this one, and then we have 1, 2, 3, 4, 1, 2, 3, 4. Right? And this would be the 4th step, and then the 5th step. Which actually doesn't have this line right there. Okay. Then we can see that it's going up by 3, and when we make our table, we can see it's going up by 3 here. And so we can write our function rule. 3 consecutively means it's going to be 3 times x. So if I try that, I go 3 times 1 is 3, and I add 3 to get to 6. Now this just happens to be a coincidence that I'm adding the same number that I'm multiplying by. Normally it's not like that, but it happens to be in this one. And then of course I graph, I put the steps down here and the number of toothpicks here. On the hexagon tables, you could see that the first desk has 6 chairs, or can hold 6 students. 2 desks pushed together can hold 10. 3 can hold 14, and 4 can hold 18. When we look at here, we can see it's going up by 4 every time, which reminds us we're multiplying the x value by 4. And this, in order to do that, 4 times 1 is 4, and then to get to 6, we'd add 2. Right? So we have our function rule here. We'd graph there, and we'd answer this question. Sarah says that 47 students can sit around 11 desks. So if we substitute 11 in, we get 44 plus 2, which is 46. And so Sarah is wrong because she's 1 short, right? But how many students can actually sit around 11 desks? Well, only 46. All right, you guys, please do not forget, pretty please, do not forget to get a parent signature on your study guide, right? Oops. So, okay, get a signature. On your study guide, because it goes in the quiz category, right? It goes in the quiz category, so you want to get all those points. Why am I doing this? Because I only had a few people that did not pass the last test, and they did not do the study guide. So I want to make sure that that study guide is done, pretty please, so that you can rock star it. And I will surprise you with some sort of function-y dessert tomorrow. I'm not really sure what it's going to be. I'm still trying to figure out what I can do that would look like a function. Anyway, have a great night. I appreciate you all. I pray for you every day, and take care.